Hello everyone, my name is Saloni and today we'll discuss a question that will be helpful to you for all physics competitive exams. And so our question says that there are four particles shown in this figure that is given below, and these are connected by massless rigid rods. Find the coordinates of the center of mass. Find the moment of inertia about an axis that passes through mass A and is perpendicular to the page. So this is our first part, this is our second part. So let's calculate the first part, find the coordinates of center of mass. Okay. So if this is y-axis, this is x-axis, so definitely this is the origin. Okay, this is our reference point. So we know that xcm, as there are four particles, so xcm is summation of mi xi divided by summation mi. Okay. Now you know so this thing, when we do summation, it actually means that MA XA plus MB XB plus MC XC plus MD XD divided by MA plus MB plus MC plus MD. Okay, so this is our XCM. So XCM, we know that MA, this is the reference point, so definitely MA xi will be 0 for. So when you are finding the xcm, that means the x component of center of mass, then first we'll write the coordinates. So this is 0 0. What is the coordinate of this point B? This is, see, this is 0 10, this is 10 10, and this is 10 0. Okay, so I've written the coordinates of uh, every mass here. Now simply MA 200, MA is 100 into 0. For MB, it's 200 into 0, because again x coordinate is 0. Okay, so this XA, XB, XC, these are the x coordinate. Okay, x coordinate of our point masses. Okay, so for C, we know it's 10 centimeter, but this isn't 10 centimeter. So if, what you can do, yeah, if you want to calculate it, if you put it in centimeters, then xcm will come in centimeters. If you put in meter, then xcm will come in meters. So it's up to you. So what we do is, let's say we convert into our meters. Okay, so this is 0.1 into md, which is 200 gram, into, again, this is 0.1 divided by M a 100 plus 200 plus 200 plus 200. Now in the numerator and denominator both are in grams, so definitely that unit gets cancelled out. So our question becomes, this is 200 into 0.1 plus 200 into 0.1. So this is divide by 700. Okay, so the numerator and denominator both are in grams, so unit gets cancelled out, and the resultant will be in meters. Okay, so it will be 0.057 meters. Okay, so when you'll solve this, this is 0.057 meters. So XCM is 0.057. Okay, which is actually 5.7 centimeter. Okay, so if you want to, if this is total 10, so if this is 5, then little bit here. Okay, XCM is little bit here. Now for YCM, you need to again integration mi divided by integration mi. So you put this 100 into y coordinate, which is 0, plus 200 into y coordinate, which is 0.1. This is for B, this is for A. For C, it is 200 into 0.1. You can see it in the diagram. And for D, 0. For D, it's again 0. Okay, so divided by again 700 grams. So when you solve this, this also comes as 0.057 meter, which is again 5.7 centimeters. So you see, axiom is here, and if this is the middle, then 5.7 something, our center of mass will be something here. Okay. Now, so the coordinates of center of, we found the coordinates of center of mass. Second is find the moment of inertia about an axis that passes through mass A and is perpendicular to the page. So it's perpendicular to the page. That means if this figure it's an XY plane, then that particular axis is in Z plane. Okay, Z axis. So if now it's rotating about this axis. So what we have to find moment of inertia. So how you find that moment of inertia? For moment of inertia, I is equal to integration mi ri square, which is ma RA square plus MB RB square plus MC RC square plus MD RD square. Okay, and now for RA, RB, RC, RD, you can see from this axis RA is 0, RB is 10 centimeter, RC is this length. So RC is this length, which is 10 root 2, and for RD it's again 10. Okay. So, and but it's 10 centimeters, so that is 0.1 meter, and this is also 0.1 meter. So you put all these values in here. So MA, now you have to take, because now we want in SI units and there is no numerator and denominator cancelling out. So yeah, now you have to take MA in kilograms. Okay, so it's for 100 grams 0.1 into RA, which is 0 square. For MB, it's 0.2 into 0.1 whole square plus 0.2 into, for RC we calculated it's 10.2 centimeters, and 10.2 by 100 in meters. Okay, so when you calculate this thing RC, it comes as 0.1414 meter. So that is what you'll do, 0.1414 square plus, okay, plus for RD, which is 0.2 into 0.1 square. Okay, so for I, finally when you add these things, I will come out as 0.008 kg meter square. Okay, so this is our final moment of inertia. That means second part has also been solved like this. Quantum particle of mass m is placed in one-dimensional box of length L. Now we assume that the box is so small that particle motion is relativistic in case this is not valid. So first we have to derive an expression for the kinetic energy levels of the particle. Second, we have to assume particle is an electron in a box of this, so lowest possible kinetic, and we have to calculate what percent, like by what percent is the non-relativistic equation in error. Okay, so if we take non-relativistic expression, so like what is the percentage gap? Okay, so simply first of all, it's a one-dimensional box. Okay, so it's a one-dimensional box, so you can write L is equal to n lambda by 2. Okay, because we know that for L, for first it is this, the second it is this. Okay, wave functions are like that. So for n is equal to 1, L is equal to lambda by 2. Okay, so simply n is equal to 2, L is equal to lambda. So here this is the general expression. So using de Broglie expression, you write it as h 2L by n. So this will become 2n and h by 2L. Okay, so these are still valid. Okay, this is valid in relativistic thing also, and this is also valid. Now what you have to change is you take energy as p square by 2, and this you can't take. Okay, what what you have to take energy, the value energy, relativistic energy is Pc square plus mc square whole square. Okay, so this is our relativistic energy, and so when P you take as nh by 2l into c whole square plus mc square whole square. Okay, this is our expression. Okay, so this is our energy expression. In first part we were required for the kinetic energy of the particle, so this is the total energy. For kinetic energy you just minus it with the rest mass energy. So this question, in our question, this m is given basically the rest mass. Okay, so E is nhc by 2l whole square plus mc square whole square, this complete square minus mc square. So this is the our expression of kinetic energy. Okay, now for B part we are given that that particle is our electron, so we take m as this, right? And we are given the length is 1 into 10 to the power minus 12. Okay, find the lowest possible kinetic energy. So for lowest possible kinetic energy, first of all I read this. For lowest possible kinetic energy, simply from the expression you can see that n is the variable, so n should be taken as 1. Okay, so simply when you take n is equal to 1 and you put everything in this expression, you put n is equal to 1, you put h is this, c is 3 into 10 to the power 8 divided by 2 into 1 into 10 to the power minus 12 whole square. Okay, plus m, the rest mass is 9.11 into 10 to the power minus 31 into c square, which is 3 into 10 to the power 8 whole square square. Okay, so this you do. Now, and also you have to minus this also, this expression 9.11 into 10 to the power minus 31 into this whole square, which is 9 into 10 to the power 16 basically. Okay, so when you solve this thing you get 4.68 into 10 to the power minus 14 joule. This is our lowest kinetic energy. Okay, lowest. This is how you solve for the B part. For the C part, by what percentage the non-relativistic relativistic. So for if you take the non-relativistic expression, so this is the non-relativistic expression for our for n is equal to 1 in a one-dimensional box. So simply if you put the value for our electron for our given particle basically, and you get 0.02 into 10 to the power minus 14 joule. Okay, so if you want to compare, this is our non-relativistic energy, and if you compare with relativistic energy, simply the percentage error, okay, comes out as 28.6%. Okay, so this is how you solve these kind of question. So next question is that express in electron volt or keV or MeV more appropriate. First part is kinetic energy for lithium to positive ion that is accelerated from rest to a potential difference of this. So this is first part. Second part is potential energy of two protons that are this much distance apart. So this is V part, and third part is kinetic energy just before impact of a 200-gram ball drop from height. This. Okay, so first we'll do the first part. That is the kinetic energy of lithium to positive ion that is accelerated from rest to a potential difference of 500 volt. Okay. So we know the delta V is equal to 5000 volt. So what will be the delta U? That will be Q into 5000 volts. So what is Q? It's 2 into E, and it's also positive. Okay, so this is 2 into 1 point. So this is actually 10,000 into E, which is nothing but 1.6 into 10 to the power minus 19 joule. So this whole thing will convert into joule. But if you want to leave it in electron volts, so E you just can write it as electron volts. This is nothing but 10 kilo electron volts. Okay, so this is delta U, which is actually equal to delta A because of division of energy. Okay, so our first part is done. Second is potential energy of two protons that are this much distance apart. So we know potential energy is Q1 Q2 divided by R. So what is Q1? Q1, two protons, that is E square into R, which is 10 uh, per femtometer, which is nothing but 10 to the power minus 15. Okay, so this is 10 to the power minus 15. Okay, so when you put K, you put the value U is equal to K this into E square, which is 1.6 into 10 to the power minus 19 whole square divided by 10 FM, which is 10 into 10 to the power minus 15 meter. Okay, so U, when you solve this whole thing, U comes out as 2.3 into 10 to the power minus 14 joule. And if you want to convert it into electron volts, so this will be 2.3 into 10 to the power minus 14 divided by 1.6 into 10 to the power minus 19, which actually you solve, you get 144 into 10 to the power 3 in electron volts. So you can write it as 144 kilo electron volts. Okay, this is U, the potential energy between two protons which are kept this much distance apart. That is kinetic energy just before impact of a 200-gram ball dropped from a height of this. So you know what it is. Kinetic energy. Kinetic energy will be equal to the change in potential energy, which in this case will be the gravitation potential energy. This is this, right? mgh, work done by gravity. So this will be equal to nothing but m. So this is 200 divided by 1000, right? Into g, which is 9.8 into, because we're given 200 grams, and this height. Okay, so what is the height? It's 1 meter. So you put it as 1. So when you solve this thing, you get 1.96 joule. And if you want to convert it into electron volts, simply divided by 1.6 into 10 to the power 19, which comes out as 1.2 into 10 to the power 19 electron volts. Okay, so you can actually see the difference between energies. This energy here, if you drop a ball, it's of the order of 10 to the power 19. And when we are talking about this energies, potential energy between two protons, something, they were about kilo electron volts. Okay, so yeah, you can see how what is the difference, the amount of difference between the energies. Okay, it's way more than. Okay, our next question says that there's a parallel plate capacitor with 1 mm plate separation is charged. So del D is 1 into 10 to the power minus 3 meter. Charged potential difference is 75 volt. With what kinetic energy must a proton from the negative plate, if it's just barely able to reach the positive plate? It's barely reach the positive plate. Okay, must a proton be launched from the negative plate? See, this is negative plate. This is how proton is launched. So if proton is launched, definitely it has to go against the electric field, because electric field is in this direction. So force on proton is in this direction, right? So definitely when the uh, uh, proton will go in this direction, this will eventually lose energy because of this force. Okay. So work done by this force will be equal to decrease in kinetic energy, right? So simply what you can do is, here the work done by this force, that is this area, the electric force, you can see what is the work done will be the change in the electric potential energy. This is delta U, and what is delta U here is Q delta V. Okay, so this is Q delta V, work done on a charged particle, and that will actually will be this work done, what will it do? It will cause basically it'll do negative work on the particle, and eventually our kinetic energy will decrease. Okay, so here it will do Q delta V. And of course, here you can see that work done is negative on the particle. Work done is negative, so work done is equal to minus delta U. Okay, you have to remember that work done by force will be equal to minus, always will be equal to minus of change in potential energy. So this is the appropriate formula. So work done is equal to minus delta U. The magnitude will of course be equal, but yeah, if you want to consider all the things, you have to write minus here. So Q delta V, this will be our final equation. So simply this, you can put Q, this is 1.6 into 10 to the power minus 19, and what is delta V here? We're given it's 75 volts. Okay, and this final kinetic energy is 0, initial kinetic energy is half into mass of proton, which is, okay, uh, we are given with what kinetic energy must a proton be launched? It just barely able to reach. Barely just able to reach, that means all the kinetic energy is lost. Okay, so this final kinetic energy is 0. So simply we have to find this only. In the question we have to find this only, minus half mv square cube. What is the initial kinetic energy? Says that final kinetic energy, it reach barely means final kinetic energy is 0. So minus minus gets cancelled. The half mv square becomes this, and when you solve this thing, and we have to find this in uh, mm, electron volt. So simply this is nothing but electron volt thing, and this is, the answer will be 75 electron volt. Okay, so our energy will be, initial energy, kinetic energy required such that it barely reaches the positive plate is 75 electron volt. Okay. The next question says that consider the gold isotope 198. So many electrons to this number, 187 A. Okay. We have to find how many electrons, protons, and neutrons are in the neutral 197 AU atom. Okay. So first of all, we know that A is equal to Z plus N. That is the atomic number, N is the number of neutrons. We know that for a gold atom, basically AU is gold. So this is 79. Okay, and this is 197. The number of, so first of all, Z is the number of protons present in the this gold nucleus. So this is 79. Okay, number of neutrons will be equal to 197 minus of 79, which will be equal to 118. So number of neutrons will be 118, and electrons, are equals to, in a neutral atom, electrons is equal to number of protons, so this is also 79. Okay. B part is the gold nucleus has the diameter of 14 femtometer. What is the density of matter in the gold nucleus? Okay. So how to solve this? Density is nothing but mass of the atom divided by the volume. Okay. So mass is nothing but 197, the mass of proton. Okay, because mass of proton is equal to mass of nearly equal to mass of neutron only. So this is the total mass divided by 4 pi by 3 into the radius. And radius, what we are given in the question, it's given that diameter is this, so radius will be of course half of it, so 7 femtometer. So this is 7 into 10 to the power minus 15 whole square. Okay, so when we solve this whole thing, this MP, that is mass of proton, this is 1.67 into 10 to the power minus 27. This is 4 pi by 3, 7 into 10 to the power minus 15 whole. Sorry, this is cube here. This is cube here. And when you solve this whole thing, you get 2.29 into 10 to the power 17. And what is the unit? It's kg per meter cube. Okay. This is the density because all of these are in SI units only. Okay. This is our second part. What's the third part? Say density of lead is this. How many times the density of lead is your answer to part B. Our answer came out to be this, and density of atom lead is not so that much. So density of AU divided by density of lead. Okay, sorry, we write it as PB. Okay, so this will come as When you divide the whole, both of these things, we get 2.29 into 2.29 into 10 to the power 17 divided by 11400. Okay, okay. So first of all, first you have to, this is not the, this is actually in this B part, we have calculated the density of gold nucleus. Okay, so this is gold nucleus. So this is the density of gold nucleus, not the entire gold, but the density of gold nucleus. So don't think like the gold, the atomic form in which we have gold, it's have this much density. No, because we know that in nucleus, we know that in nucleus is very densely packed. So this is not actually density of gold. This is actually density of aluminium and nucleus basically. Okay, so don't confuse this. Okay. So this will come out to be, when you calculate this, this will come out to be 2 into 10 to the power 13 times the density of lead. Okay, so that you have to see that this thing, this actually shows that the nucleus is very densely packed. Okay, but yeah, in atomic form you have electrons. Because of it, volume increases drastically, and that's why density decreases. Okay, so this is how you solve these kind of questions. Okay, our next question says, consider the lead isotope. So mass number is again 207. Number of, you know that lead, for lead Z is equal to 82, Z is equal to 82. So our number of protons will be 82, only number of electrons. In neutral Z will be, number of electrons will also be 82, electrons, protons. And what about neutrons? It will be A minus Z, so it will be 207 minus 82 will come out as 125. So this is the number of protons, sorry, neutrons. Okay, so this is part A. Our B part says the lead nucleus has a diameter of this. What are the electric potential, electric field strength at the surface of lead nuclei? Okay, so diameter we are given 14.2 FM. The radius is, of course, will be 7.1 FM. That means 7.1 into 10 to the power minus 15 meter. Okay, so now we are given the we have to find the potential. So you calculate by this 1 by 4 pi epsilon naught, you know, use it 9 into 10 to the power 9. What is Q? That is the charge on our lead atom. We know it is the number of protons into the charge on one proton. So this is 82 into 1.6 into 10 to the power minus 19, right? Divided by R, which is radius, that is 7.1 into 10 to the power 15. So this is our potential, and when you calculate this whole thing, you get 1.66 into 10 to the power 7 volt. Okay, this is our potential. For electric field, what you'll have to do? For electric field, your electric field at the surface will be this. Okay, so put all of this 9 into 10 to the power 9. Q is again 82 into 1.6 into 10 to the power minus 19 divided by 7.1 into 10 to the power minus 15 whole square. Okay, so when you calculate this whole thing, we get 2.34 into 10 to the power 21. And of course, unit of our E, that is electrical, will be volt per meter. Okay, so this is how we solve these kind of questions. Next question says, figure shows a stream of water in steady flow from a kitchen faucet. At the faucet, the diameter of the stream is this. So here we have this diameter. The stream fills a 125 centimeter cube container in this much time. Okay, so this is the volume of the container, this is the time. Find the diameter of the stream 13 centimeter below the opening of the faucet. So basically what we are given is that this here will fill this container in 16.3 seconds. Not this stream, see, because dv by dt is given, will be same here also and here also. Okay, so we are given dv by dt, which is 125 centimeter cube per 16.3 seconds. So this come out as 7.67 centimeter cube per second. Okay, so this is given, actually this is a into v1, a1 into v1. Okay, now the diameter is given, which is equal to 0. So I'll write it as this, v d1 square by 4 into v1. This is a1 v1. Okay, so if you put everything, this is pi into 0.96 whole square divided by 4 into v1. This is 7.6. Sorry, v1 is not given. v1 I'll write as this, and dv by dt is given 7.67. So because thing is also in centimeter, so our v1 comes out in centimeter per second. So this comes as 6.67. This is our dv1, and this area when you solve this, when you take it this side, and basically when you solve this whole thing, it comes out as 0.7247. Okay, so this whole thing comes out as 10.6 centimeter per second. Okay, so this thing was in centimeter cube per second, this thing was centimeter square. So v1 comes out as this is the velocity at this point. Okay, now because in the question we have to calculate the diameter of the stream here. Okay, you'll use Bernoulli's theorem. So using this, so at P1, okay, see, this is the point. If I take this is P1 and this is P2, so this P1 here, it's P naught because it's the atmospheric pressure. When we talk, sorry, here we took this as our reference point, so this is P naught. P1 basically, if we talk about this is also P naught, this is P1. So P1 is equal to P naught, P2 is also equal to P naught. This is, we have calculated V1, and this is V2. And if we talk about Y1 and Y2, okay, uh, so if we take this so basically our Y2 is equal to 0, and this y1 here is 16 it's 13 centimeter. Okay, so we'll put everything. P1 is P naught, rho is 1000 into 9.8 into 0.13 plus half into 1000 into v1, which is equal to 0.106 whole square, is equal to P naught plus 1000 into 9.8 into y2 is basically 0 because this is the reference point, so y2 is 0 plus half into 1000 into v2 square. Okay, so this p naught gets cancelled, this is 0. So if you have to solve this whole thing, and if you take this is 500 in the denominator and you solve, so v2 uh, finally will come out as 1.6 meter per second. Okay, so this is how you solve for part A. No, sorry, there is no part A. So this first we have calculated V2, Now, because you know the flow rate, so you can just use A2V2 is the flow rate here. So A2V2 is equal to 7.67 centimeter cube per second, and this A2 is equal to pi d by 2 whole square into V2. This thing first will convert into centimeter per second. Here, why this came in meter per second? Because everything was in SI units when we solved that. Okay, so this is 7.67. So V2 is equal to, when you when you put V2, this is pi d square by 4 into V2, which is 160 into V2 is into 6 points. This is 7.64. From here, D comes out as 0.247 centimeter. So question says there is a large man sits on a four-legged chair 3 feet off the floor. Combined mass of the man and the chair is 95 kg. If the chair legs circular and have a radius of this at the bottom, what pressure does each leg exert on the floor? Okay, so we know that chair basically talking about it has four legs. Okay, so there are five legs sits on. So basically, we can say that the force that is applying downward is mg. Okay. Now the combined mass of the chair as well as our man is given as 95 kg. So we know the net force downward is 95 into 9.8. Okay, Newton. So and the now the question says if the chair legs are circular and have a radius. So the legs are circulars and radius is 0.5 centimeter, which will convert into SI units. So it becomes 0.5 into 10 to the power minus 2 meter. At the bottom, what pressure does each leg exert on the floor? So of course, this pressure will be divided among like this weight basically will be the pressure will be equally divided among the four legs. Okay, so if we if we calculate the force on one leg, so that will be mg by 4, but force will be equally divided among all the four uh, legs of the chair. So the net force, so pressure is, we know it's net force divided by area. So mg by 4, and area we know is pi r square. And when we put all the values, uh, m we put as 95 and g we put as 9.8. Of course, we calculated that 4 into pi and radius is 0.5 into 10 to the power minus 2 whole square. So when we solve this whole thing, we get 2.96 into 10 to the power 6 pascals. Okay, so this is our answer. This is how you solve these kind of questions. So thank you for watching this video. If you like our content, please subscribe to our channel to learn more about physics.